classification, what is the use of statistics, and then what are the different types of data variables, how we have to process the data. So preparing data is the main task as far as our ML processing is concerned. So if the data is ready, then you can apply the various algorithm and process it. So that is the main task. And somebody asked a question like so when you will go for manual data clean, just now I saw. So when your data is very sensitive and you believe that if you do the data cleaning process manually, it will make sense. Then at that time we will go for a manual process. So in all the other cases, we'll go with tools and other automated process. Okay. So now we saw what how our machine learning processing differs from traditional programming. So where your traditional programming accepts data and the logic and process it and gives the output, while machine learning will get the data and the output and it will give you the logic behind it. So it trains itself to find out the logic behind it, and then based on the data and the required output, and then it gives the prediction. And we also saw what how it machine learning does and how it works and why we go for machine learning. So all these things. And next is so we saw what is supervised machine learning, where you have labels and you do training. And then you we also saw unsupervised learning, we don't have label. So here we just based on the similarity, you group the element data points based on the similarity and then do it. So when coming to supervised learning, we what is regression and classification. In case of unsupervised learning, we'll go with the clustering and reinforcement learning. When you not able to apply either supervised or unsupervised machine learning method, in that case you have to go with reinforcement learning. So it's a trial and error rule. So you will apply in situation where it is very difficult to apply either a supervised or unsupervised learning method. But here you have to be very clear with the goal and the environment and what actions you want to perform and what you want to achieve. So then your RL method will be easy. So now we'll just see the use of all the machine learning algorithms, and I'll just go with one. I will give an example for regression algorithm, simple and multiple linear regression with. So I'll tell you how to train and how to build the model and how it you will test the hypothesis. Okay. So first one is your regression algorithm. So whenever these are all the algorithms, I'm just going to give an overview. Regression algorithm, classification, clustering, association, anomaly detection, sequence pattern mining, dimensionality reduction, and recommendation system. So you can categorize either any one of this category algorithm your problem. So first regression. Whenever you go with predicting continuous value, then we will go with regression algorithm. So these are all the different regression algorithms available: linear, polynomial, exponential, logistic, and logarithmic. And when I say classification, so we are predicting a set of items, class or category. So when you want to do that, then you will go with classification algorithm. So these are the few classification algorithms: KNN, decision trees, random forest, support vector machine, and naive Bayes. And whenever you want to summarize or structure the data, then we will be going with the clustering. Based on the similarity, we will be able to group it. So the in that case, we'll go with the clustering algorithm. So K-mean, DB-scan, mean-shaped, hierarchical. Next, association. So association, as we all are familiar with it. So associate co-occurrence. If X occurs, then Y will also occur. So co-occurring items or even when you want to go with such prediction, then we will apply association. So the famous algorithm is a priori and anomaly detection. This is for discovering abnormal activity or fraud detection. So in that case, you will go with anomaly detection and sequential pattern mining. If you want to predict what will be the next event, what will be the next data, then in the sequence, then we have to go with sequence pattern mining. The next one is dimensionality reduction. So we use dimensionality reduction. So if I have a very big data, so I just want to reduce the size of the data by extracting only the important feature from the data set. I may have thousands and thousands of features, but among the thousand features, only a few features will be more important. So I will use that feature alone for my prediction. So in that case, I'll go with dimensionality reduction. And the last one is recommendation system. It is used to build the recommendation engine. So anyway, so what if you want to suggest a product, a book, anything. So in that case, we'll go with the recommendation system. So these are all few machine learning algorithms that are used. And now we'll start with the linear regression machine learning. Linear regression machine learning. If the linear regression, it says that it is a supervised machine learning algorithm. So what you're going to find out is you're going to find out the linear relationship between the data. So you are assuming a linear relation between a dependent variable and an independent variable. So if you consider any scenario, some variable will be dependent on few variable or one variable, whatever it may be. So you are going to identify that relationship, linear relationship between a dependent variable and an independent variable. So the value of the dependent variable of a linear regression is a continuous value or a real number. So it is a real number. So whenever I say linear regression model, it is going to give the relationship between a dependent variable and a independent variable via a slope. So now here before getting into the model, first you have to know what is regression analysis. So when you combine the regression analysis and correlation, so we have already seen what is the correlation, the relationship between two variables. So you will be able to predict the performance, future performance using the historical results, data which is already available. So this combination, so when you say correlation, it gives you the degree of relationship between any two variables. The same thing, regression also defines the relationship but more precisely. So when I say regression analysis, you can use data relevant variable to develop a prediction equation. You are going to build a model. So if I say y is equal to a plus bx, then that x value, so depending on the x value, your y value will be predicted. So the relevant variable to develop a prediction equation or a model. So it generates an equation. You're going to generate an equation which is going to describe the relationship between one or more variable and the response variable. Here you will say it as a response variable predictor is the input and your response variable y, and to whenever you are given a new value it has to predict it correctly. So that is what given. So we will represent the linear regression model. So the slope, so here you have a line, the slope straight line represents the linear relation. As we saw, whenever I go with a scatter plot, so I have to draw a line in such a way that all the data points are closer to it. So if it is like that, then I call it as a best regression line. So here also the same thing we are going to talk about. Here, the linear relationship that fits the given data best is called the regression line. You can also call it as a best fit line. Suppose if I want to describe this, how to describe it? Y is equal to beta naught plus b1 x plus epsilon. So here epsilon is a random error. It is very difficult to find out the error. So most probably it is not predictable. But your y and x that is given in your problem statement itself, so it is available in the data set which you have, y and x. Only thing you have to predict is your beta naught and beta 1. So beta naught is nothing but your y-intercept. What is that y-intercept? See, the height here, the height from the line to that x-axis, this gap, you will call it as a beta naught, and the slope of the line is beta 1. So that is what given, intercept of the line, y-axis, y-intercept, you call that as y-intercept. So the line touches the y-axis from that to 0 x-axis. This height is said to be the beta naught. So linear regression coefficient beta 1 is nothing but the slope of that line. When your problem is to identify a value for beta naught and beta 1, because your x and y value is already available in your problem. So whatever data set you have, it is available. So the value for x and y variables are training data set, it is available. Only thing is you have to predict beta naught and beta 1. And obviously error for a very good model, your error will is negligible, so you will not concentrate on the error. Okay, so types of linear regression. The linear regression is further divided into two: simple linear regression and multiple linear regression. What is simple linear regression? If a single independent variable is used to predict a value of a numerical dependent variable, then you call it as a simple regression. Look at this example. I am having only one variable x, which is the independent variable, and y is the dependent variable. The value of y depends on the value of x. So this is what it means. Only one value. It depends on only one value to predict the value of y. Now in this case, I'll call this linear regression as simple linear regression. When you have more than one variable based on which your y is predicted, for example beta naught plus beta 1 x plus beta 2 x2 plus beta 3 x3, it goes on. So now here x1 x2 x3 all are independent variable, but your y variable dependent variable depends on more than one independent variable. In that case you will call the regression as multiple linear regression. So the dependent variable, number of dependent variable decides whether it is a simple linear regression or multiple linear regression. So now next one is a linear regression line. So the line you are going to draw in such a way that all the data points are closer to that line. A linear line, and one more thing is the variable y and x. The relationship between your x and y variable is shown in this line. A linear line showing the relationship between dependent and independent variable. Here y is a dependent variable because the value of y depends on the value of x. So here if you see, the y value keeps on increasing as you increase the x value. So you call this as positive linear relationship, because as you increase x, y is also increasing. In the second example, you see the line is downwards. As you increase the value of x, the value of y is decreasing. That means negative linear relationship. So this is all about your linear regression line. Now, our aim is to calculate the best value for beta naught and beta 1. So, in case of simple, and in case of multiple, you will go have beta naught, beta 1, beta 2, etc. It goes on. Calculate the best value for beta naught and beta 1, because x and y is available in the data set. The only thing you have to find is beta naught and beta 1 to find the best fitting line. How to find it? I have to apply the cost function. What is that cost function? So here I have mentioned it as a naught and a1. It is nothing but beta naught and beta 1 only. the coefficient of this line beta, when you give the value beta naught and beta 1, what is that, you draw, you apply different values and draw different line, and you find out which line is best fitting. So based on that you will select the line. So different line of regression you draw, and the cost function is used to estimate the value of the line. So which is having the less cost, then that will be considered to be the best line. So the cost function will optimize the regression coefficient or weight. It will measure how a linear regression model is performing. So we can use the cost function to find the accuracy of mapping function. So because y is equal to beta naught plus beta 1 x plus epsilon. So here this cost function is used to find out the accuracy, how well it is, y is predicted based on the value beta naught and beta 1. So which maps the input variable to the output variable. So the mapping function which you use will be called as an hypothesis function. So next important thing before getting into linear regression model, now you have to know few terms. That the first one is mean squared error, MSE. So we use mean squared error as a cost function. So it is nothing but average of squared error occurred between the predicted value and actual value. So your predicted value is nothing but a1 xi plus a naught. So it is nothing but a naught, and a1 is nothing but beta naught and b1. That is your predicted value, and y is your actual value. What is the difference between your predicted value and actual value? The square of those, sum of all square, and find out the average. That will give you the mean squared error. So which will be the cost function. Okay, so this you should remember. Next one is residual. So what is residual? So it is nothing but the distance between the actual value and the predicted value. So what is the distance? So my predicted value is 250. My actual value is 225. Then the difference 25 is said to be the residual. If the observed point is far from the regression line, then what will happen? Obviously, your cost function will be high. So, the closer the points to the linear regression line, then your residual will be small because it is approximately correctly predicted. It is more or less equal to the actual value. So, if it is equal to the actual value, then obviously the residual will be very small, and hence the cost function will also be good. So that is what it means. Now you see, the residual value is the discrepancy, that is difference between the actual and predicted value. So the actual value is here, but my predicted value is here, that orange color. I have put a scaly bracket. This is the difference. So predicted value of y for a particular xi, this is the predicted value which is available on the blue line, but my observed value is somewhere here, observed value of y for xi. So the difference between this xi and the observed value xi, this distance is said to be the residual. So the distance of the plotted points from the line will give you the residual line. So here the procedure to find the best fitting is least square method. So this alpha is nothing but your beta naught, and this is the slope, it is nothing but your beta 1. So this is what I was saying, intercept, y intercept is your beta naught, and this slope is your beta. So this is all regarding residual. Now let us take look into simple linear regression. So in simple linear regression, your, as we saw, your dependent variable depends on a single independent variable. So when you see the formula model, we should not say formula, it is a model. Y is the dependent variable and x is the independent variable, and beta naught and beta 1 you have to predict. So here beta naught, I have given it as a naught, it is beta naught. It is the y-intercept. So it can be obtained by putting x is equal to 0. What will happen? Whatever y distance, that will be same as your y. It is the, but beta 1 is the slope. It will tell you whether the line is increasing or decreasing. And for a good model, as we saw before, your error is negligible. So Beta naught and beta 1 are said to be regression coefficient, and beta naught is your y intercept, and beta 1 is the slope, or you can also say weight, which specifies the factor by which. So you are multiplying the x by beta 1, that is why it is called as weight that specifies the factor by which x has an impact on y. So whatever value you are giving based on the beta 1, the value will be calculated for y. So the impact of beta 1 over y value. So it is to be the slope of the regression line. So now consider I'm going to find out the value, used car value. Now what will happen? I want to buy a used car. That is my parameter y, which is the dependent variable, and beta 1 plus beta naught plus beta 1, how many kilometer I have you already used. So that will be my dependent. I am considering that as an independent variable x and your year. So I can build a model like that. What I want to predict, I want to predict the used car cost, and I know the number of kilometers the car is already used. So based on the number of miles driven, I'm going to predict the cost of the used car. So I can build a model to represent this using the formula y is equal to beta naught plus beta 1 x plus epsilon. So now let us consider an example. I have a data set like temperature and ice cream sales. Now, when you consider this example, which is dependent variable and which is independent variable? Ice cream sales depends on temperature, or temperature depends on ice cream scale. So your input is depending on the temperature, your ice cream scale, sales will be improved. We cannot say it in by other way. Ice cream sales will decide the temperature. No, it is wrong. So that means here your temperature is the independent independent variable, and your ice cream sales depends on the temperature. That means ice cream sales is the dependent variable. Now I will find out the sales of the ice cream depending on the temperature. So my x value will be temperature and your y value will be the ice cream. So now I have got a data set. What I need to do, I have to plot the data set in the scatter plot. As I told you, you can represent the data points using a scatter plot and then fix the regression line. Now I have marked all the data points on the graph. Now see all the data points for the data for 214.2, whatever the value, I have marked everything in the scatter plot. Now what I need to do next, I so before doing the analysis I have to plot it. So now, after plotting it, I can analyze what I'm going to analyze. There are three possible cases. One is the first case, my beta 1 is less than 0. When it will happen? If the variable x has a negative impact on y. So, when my x increases, my y value decreases. What will happen? Your beta 1 will be less than 0. In this case, your value will be less than 0. And the second one is beta 1 is equal to 0. What will happen? It directly depends on beta naught. Whatever you give, y value will be beta naught. So if x changes, there will not be any change in y because beta 1 is equal to 0. That means x has no impact on the y value. So the third case is beta 1 is greater than 0. That is, x has a positive impact on y, which means whenever the value of x increases, y will also increase, and vice versa. Also, you can say y increases, x will also increases. If you see all these things, they are all quantitative association. If you want to give quantitative, then I have to go for some numbers, not like this. So less than 0, equal to 0, greater than 0, it is okay. So what I am saying, it is negative, it is positive, it is no impact. So all these are quantitative analysis. So using this, we can have a quantitative qualitative association, but what I need is quantitative association. So if I want to have a quantitative association, then what I need to do is we have to go for correlation. What is correlation? You are finding out the relationship between two variables, the measure of strength of linear association. So we are going to consider only linear association because it is linear regression. So if the variable, how far the variable x decides the value of y, how far they are related. So if you want to identify, analyze, then you have to go for correlation. So correlation is a statistical technique which is used to find out the degree of association or relationship, strength of linear association between two variables. So this is identified using correlation. So when I will, there is here also, if you want to say qualitative, then I will say it is low correlation, high correlation, and less correlation. So here it is less, not high. This side. So if you say high correlation, it is negatively high. Here it is positively high. The center one is low correlation. How to find this correlation? Co- you have to find out the mean value of x value. That means find the add all the value and find the average. The same way y value, and you have to apply the formula. You will get the correlation. Okay. So based on the value, you will decide whether it is low correlation, high correlation, or zero correlation. Positive R indicates that there is a positive relationship between x and y value. So negative relation indicates that it is a negative value, R value indicates that it has a negative linear relationship. Anyway, your R value will range from -1 to +1. So the strength increases as R moves away from 0 towards, either it should be -1 or it should be +1. Either it is negative linear relation or positive relation. Consider the first case where your P is equal to 1. So here when you see positive correlation, because as x increases, your y is also increasing. And the second diagram, it is a negative correlation where all the points you see, whenever you increase the x, your y value keeps on decreasing. So in this case, you will consider it as a negative correlation. So you consider this when the R value, so it's a probability you consider as 1. If the value is between zero point 0.1 to zero point 0.3, when you calculate, it is said to be weak. And if it is zero point 0.4 to zero point 0.7, it is said to be moderate. And when you have a value zero point 0.8 to 1, that means it is strongly correlated. So this is how you identify as low, and then moderate and strong correlation. Next, not perfect. See, in the first diagram, I have drawn a line, but many, even though it is positively correlated, many points are away from the line only. So that is why your value is 0.10. And here, if you see in the second diagram, it is negatively correlated. But even then, I cannot say it is perfect negative because many points are away from the line. So I am getting negative value. And the third diagram, no correlation at all. P is equal to 0. There is no, you are not able to fit any line. All the points are scattered. So these are all the cases of correlation. So next, regression. So now we'll say take an example. I'm just going to take the experience and salary of an employee. So as we saw, we have many columns available, but whenever I want to fix a salary, I think it depends on the experience. So I'm considering here my data set contains your experience and your salary. So already the salary and experience is given. Now what I want to do is, if my experience is 5, what is the salary I can expect? So I have to build a model based on the data set available, train it, and it has to predict the correct salary for 5 years. So how to do it? First thing is I have to find out which is dependent variable and which is independent variable. Here, dependent variable is my salary and independent variable is experience. So y is equal to mx plus c. In this, x is the independent variable which is experience and y is the dependent variable which is my salary. And we all know, so this is the y-intercept, your c and beta naught, and then this is the slope. So I'm going to draw a scatter plot and draw a line like this linear regression line in such a way that all the data points are close to this line. So I have to draw. Now, if I give 5 years as experience, let us find how we will find the salary for 5 years. I have a formula. I know the X and I know Y from my data set. I have to train it and then I have to find out the value for it. Now, let us put the Y variable and the X variable in the formula. Y is nothing but your salary and X is nothing but your experience. Now, salary is equal to C plus M into experience. Now, what I need to predict, as we all know, we have to predict the y-intercept and the slope. So, if we are able to predict beta naught and beta 1, then I can easily get the value. So, now randomly I am assuming m is equal to 5 and c is equal to 30. So, this is the value I am going to. So, let me consider based on the value that c values is from 0 to 30 approximately. I am assuming. Let me consider that slope as at 5. So now what I am going to do? Salary equal to C plus M into 5. So now C is 30, 30 plus 5 into 5 is 25. So approximately I'm calculating the salary as 55. How you are able to do it? Based on the historical data. So based on the data we have, we are going to train the model and we are going to find out the salary. So now, how we will find out this is the value for beta naught, this is the value for beta 1. So we should, which line should I take? I should draw. So I cannot draw only one line like this and I cannot say that this is the best line. I have to find out which line is best line. So I will draw different lines. So regression line. So and then see, I have drawn three line. Consider one, line two, and line three. Among these three line, I have to find out which line is the best fit line. How to find out? So by looking at the diagram, I can say line two is more appropriate for the data point because it goes through all the data points. The line which is near to all the data points will be selected. But how to find out that automatically? So now statistically I have to apply some function and then I have to find out the best fit line. Yes, I will apply ordinary least square method function to find the best fit line. What is that ordinary least square? So I'm going to find out the difference actual value, the residue of each and every point and square all these things and find add all the value to find out the least square value. So ordinary least square. So now what is that even? See, look at this point. So E1 is the actual value is here on the line and it is deviated from the predicted one. So that distance, so E1 square, E2 square, E3 square. So for everything, you will find out the difference and you will calculate the OLS. So ordinary least square. So which line is having the least OLS value? That is considered to be the best fit line. So I will draw the line and see, I will calculate for the line one. I will calculate the difference between the predicted value and the actual data points. The difference I will square it and I will add all the value and I will find out one. The same way I will find out OLS for second line. The same way I will find out for third line. So after finding out the OLS for every line, I find this line, the line, I consider this as line 1 or line 2, whichever. The line which is having the least value for OLS is considered to be the best fitting line. Now I have fit the line. Best fit line is found using the ordinary least square method. Now what I need to do, I have to go for prediction. So the value in the line is predicted value. As I told you, whatever you have drawn as a line, the value on that, the corresponding x value, the value on that line will be the predicted value, and the original data point is also given. So you are writing the predicted value as y cap, and error. What is the error? The difference between the actual salary and the predicted salary, that is going to be the error. So that you want to calculate. So I'm calculating the distance between the actual value and the predicted value, and its square value is OLS, because the error, the square value, if you find out even, so this is going to be y cap minus y1. So see, this is the predicted value, so which is the on the line, and this is the actual value. The difference between the predicted value and the actual value, you see, it is minus 5. For the second value, it is minus 10. Now I want to find out E1 square plus E2 square. So you square it, 5 square, 10 square, all. So if you square all those things, I'll have the OLS. So whichever line has the least value, that will be considered as the OLS, least best fitting line. Okay, so this is how you will fit the line. So next one, now let us consider a big data set where you will have a scope to analyze. So now what I want to do is I'm going to consider a weekly magazine. I'm just going to predict something. What is that? So I want to investigate the feasibility of starting a Sunday edition. So for weekdays, I have distribution, but I want to start a special Sunday edition for a metropolitan newspaper. So I will obtain the information from a sample of 31 newspapers. So their daily Sunday circulation and the name of the newspaper and the place, everything is given. So now based on this, so newspaper is given, name is given, daily how much sales is given, and Sunday sales is also given. Now, what I have to do is, based on this, I have to find out whether if I start a Sunday edition, is this feasible or not. So now, the same way, if so what, 200K, so here to 391, so I will check whether at least 200,000 papers will be sold. Is that possible? So that is my x value. So x is my 200. I have to predict beta 1 and beta 2, beta not, based on that. Now I will just point all the points on the scatter plot. So next what I need to do, I have to fit the line. So I have to, while fitting, I have to check. I will draw more line, as I said. I will check whether this line is suitable or this line is suitable. Based on OLS, I will select which is whichever is having the least value. So based on that, I will select it. Now here you see Sunday. Sunday is a dependent variable which you want to find out. It is take a decision is taken based on the daily circulation. So beta naught plus beta 1 into daily, so that is what given. Now I want to find out beta naught and beta 1, so you can easily find. So you have this OLS function, so this function will give you the beta 1. So and then by applying the value beta 1 with, I know y, I know x, I know beta 1. Now my beta naught is easily predictable. I'll find out the value and then I will apply. So in mathematics and statistics, when I say covariance, so it is also a relationship between two random variable. So it indicates whether the variable move in the same direction. So same direction in the sense, if x increases, y should increase, then it is said to be positive covariance. So variance in the sense, as we saw, the difference. So negative covariance, it reveals that when it moves in the reverse direction, then you call it as a negative covariance. So now, how to validate whether it is a good equation or not? I have predicted some model. Now I have to find out. So my dependent variable is y and independent variable is x, and I know beta naught and beta 1. So, how to validate whether what I have designed is a good equation or not? So, in order to find out that, I'm going to use r square. R square. So, I will calculate the value for r square, and this is the coefficient of determination. So, I will find out the value, and based on that, I will decide whether it is a good or bad model. So, yeah, R square method is a statistical method which finds the goodness of it, how far that line fits perfectly. You should find out the R value. The high value of R determines the less difference between predict and actual value. That means your model is very good. When you have a high value for R square, then your model is a good model. And your R square method is called coefficient of determination or multiple determination. This is the formula. R squared is equal to explained variation divided by total variation. So how to identify whether good or moderate regression equation? I have to find out, or I think some disturbance is there. Somebody has not muted. Ma'am?
Yes, ma'am, I'm seeing that.
Yeah.
I don't know, save money. Okay, ma'am.
Okay. So the proportion of variation in y, it is explained. Now you are able to see my presentation, ma'am? Is it moving?
Yes, ma'am. Yes, ma'am.
Okay. So the measure of variation. So you are going to find out the R square. So depending on the value of R square, if it is high value, then that means there is less difference between the actual and predicted value. So you can calculate. So now, what is R square? Explained variation SSR and SST. So it varies between 0 and 1. So now let us see what it is. So measure of variation y bar. So y bar, if I say wherever I have used y bar, it is nothing but average of y value. So you sum all the y and divided by n. So and if I say y cap, it is the predicted value. So from the regression line, whatever value I get for that particular x, so that is my y cap. Now what is total sum of squares? Regression sum of squares plus error sum of square. And what is total variation? Explained variation plus unexplained variation. Now I want to find out what is that explained variation and unexplained variation and total variation. So total variation is SST is very simple. So which is nothing but the difference between your actual y and your mean. So that square that will give you the total variation. And when I say explained variation, it is the difference between the predicted value and the mean value and the square. So that will give you the SSR. And the unexplained variation is nothing but the actual value and the predicted value square. So these are all, this is how you calculate the explained variation, total variation, and unexplained variation. So you will apply this in the formula R square is equal to explained variation divided by total variation, and if you will find out the R square. If the value is high, then it is a good model. So if it is less, then it is bad. So we will classify like this. If R square is greater than 0.75, then you can consider it as a good model. So once you build the regression equation, then you can check whether it is statistically significant, whether it is X is affecting Y, etc. But so your model is good now. When you get a value greater than 0.75, it is good. If it is less than zero point 0.5, it is bad. So if it is greater than zero point 0.9, then you can say it is very good. Now what you have to do? I have built the model. Now I have to conduct the hypothesis test and find out p-value. So now, so you are significant. Whether the model is significant, you will find it. So whenever we have already seen what is p-value. Whenever when I calculate, if I get a p value less than 0.05, because only 5% is allowed. So if I get p value less than 0.05, it is significant. Otherwise, we have to think about the variable which we have used. So that is more. So the dependent variable. So independent variable we have taken to calculate the dependent variable value. So that you have to rethink about. So when you have for example, your R square value is good 0.65, but your P is, while P is significant. So what is the problem? So you have to, that means, so you can still frame a good model by considering other variables, without considering only one variable x1. You can include some other features to find out the y variable. So, and one more reason for this is one is significant and other is insignificant in the sense, then your data may be skewed data because of that also it may happen. So, in that case, you will go with log x. So next, multiple linear regression. As I told you, if one variable is not sufficient to find out the value of an independent variable, then you will have to go with multiple dependent variable. So here comes into picture multiple linear regression. So y is equal to beta naught plus beta 1 x plus beta 2, etc. So here, as we know, y is the independent dependent variable and x1, x2, x3 are independent variable, and these are all the regression coefficients, and these are all slope or weight of the specific factor. Now let us consider an example. The same example we can consider. I want to find out the used car price. I cannot find out the used car based on the number of miles it has run. So I have to consider few more features also. What is that? Year, car year, production year, month, how many month, mileage. So many dependent variables are there. So you assumptions are validate once the model is built. Otherwise, what you have to do? You have to change the variable. So now I'm considering the formula. I'm building the equation y is equal to beta naught beta 1 x1 beta 2 x2. Here x1 x2 are independent variable, and these are all coefficients. Now before starting into ml, we have to make some assumption. So the assumption number one is the model is linear in parameter, because I'm going to consider only linear. I'm Since I am using linear regression, I'll consider only the linear. So next assumption is you are independent and identically distributed. So your value is independently and identically distributed. Mean is zero. Constant variance is there and independent of each other. So all these are assumptions about error. So you have to make all these assumptions. And the third assumption is about the predictor. It not be random. It should be measured without error and linearly independent of each other. And the fourth assumption is about the observation. Obviously, it should be reliable. So these are the assumption that is made. Now let us take an example: the car data. So the data car. So here in the data set given, there are 81 observations. So it is given as 81. Now, what I am going to find out? I want to find out the cost. So, to model, what is that? Volume, HP, MPG, SP, WT. Now, our interest is to model the average miles per gallon. I want to model for miles per gallon of a car based on the other variable. I have to find out what is the average miles per gallon based on the other variable, in the sense based on the variable volume, horsepower, speed, and then vehicle weight. So what is the impact of all these four variables on mpg? So that is what we are going to analyze. Now, as I told you, before starting into anything, we have to draw the scatter plot for with correlation coefficient. I'm going to take all the variables hp, mpg, volume, sp, and wt. I have drawn a scatter plot for each and every pair. See, the central diagonal value has the HP, MPG. So in the x-axis, and wherever it meets, then it that is going to be a scatter plot for that. The first scatter plot in the second row first column, it is for HP and MPG. So that if you consider that, so it is having a negative. So based on that, you can decide it is having a negative correlation, say minus 0.73. So if you want to go against MPG and then volume, again it is having a negative. So MPG and SP, it is having a negative. SP and HPC, it is positive, it is going up. And then here if you see volume, and so likewise volume and SP, it is positive. So WT, weight and HPC, positive. Weight and MPG, it is negative. Weight and volume, again it is positive. SP and WT, it is positive. So you are plotting a scatter plot to identify this first. Now, I just want to estimate the value, all the values I'm going to find out. So, in order to find out the value, I want to find out R square. I said if I am getting an R value, very good R value, then greater than 75, my model is good. Now, I have to, I just want to find out whether my MPG depends on volume, horsepower, speed, and weight. So, in order to identify that, let me calculate all these values. So, when you apply that, the star indicates, so the probability, so that column. So here it says the significant, that gives the p value significant. If the, as we know that if the p value is point less than 0.05, then it is said to be significant. Now it is your intercept you is significant, so no problem. When you consider volume, no, it is zero point 0.5, it is not that much significant in this model. Horsepower, yes, it is significant. You see, it is minus something, so it is significant. It plays an important role in predicting the Y value. And when you say SP, yes, it is also significant because it is less than 0.05. And WT, it is not significant. So from this table, shall we conclude that only two significant variables are there? One is HP and another one is SP. So apart from that, all the others are insignificant. So we cannot consider like that, because when you select many features, and based on this p value, we can find out the significant. But as an engineer, if I consider only this one, and if I say among all these parameters, based on the p value, only SP and HP is significant, and if we leave volume and weight, then we cannot say like that. Now what we should do, I have to predict it for everything. Now, I will consider I will reformulate. Let me reformulate it. So, I will consider this MPG. Now, previously, what I did, I use volume, horsepower, speed, and weight. Now, as per my prediction, only two variable is significant. One is HP and another one is SP. So now, will I be able to formulate a model for MPG depend based on HP and SP? Yes, let us try. So MPG, now I'm going to model using HP and SP alone. Now, see, only volume, MPG on volume, if you find, you see, I have removed these two values. One is volume and WT. But I cannot say that only HP and SP alone is significant. How to cross verify it? Let me calculate the MPG on volume. Now you see, I'm calculating. Now the probability is in minus 3.82 E minus zero 0.07. That means the volume is significant, but somewhere it is going wrong. So its significance is not important in the Y value. Now consider the weight. Even this is significant. You see 4.38 E. So they both are highly significant, volume and weight. Now, here is the problem. When R square is less, so they are highly significant. So we can say like, but volume and WT alone is not significant. So what I should conclude now, even if I see On the whole, if I consider your volume HP and SP is significant, but individually, if I consider my volume is also significant and WT is also significant. Now, let me build a model with WT and volume. Now, you see, again, there is a problem. So, I removed WT and volume and I tried MPG based on WT, it showed significance. And I tried MPG based on volume, it is also significant. But when I combine, now since I consider both are significant, let me include both and find out the equation. So my MPG Y is depending on WT as well as volume, weight and volume. Now you see, again it is more. That means it is less significant. Now this volume and WT from this table, we can say it is insignificant because the value is greater than 0.05. So now what I should do? I have to come to a conclusion. What is that? Let me consider this volume and weight. So when I say volume, so volume and weight are highly correlated. See, WT and volume, if you see these two, they are positive. If volume increases, weight also, they are highly correlated. So that means highly correlated, almost it is 1. So what it means is here is the problem of collinearity, multi-collinearity problem. So significant variable becomes insignificant. So you have to identify whether any multi-collinearity problem is there. So when you do this ask a test, you will be able to identify multi-collinearity problem. So from this analysis we can identify that both volume and weight are significant. Due to that, they are highly correlated. Because of that, multicollinearity problem has resulted. So both the variable become insignificant. Now, finding the multicollinearity problem using VIF, variance inflation factor. So you can how to identify the multi. Yes, madam.
Slide is not moving, ma'am.
It is not moving. Now you are able to see. Yeah. So finding multicollinearity problem using VIF, variance inflation factor. So here you have to find a value which is greater than 20. So now you are able to see, ma'am.
No, ma'am, only determining the coefficient. That slide is visible.
1 second. Is it okay, ma'am? You are able to see this scatter plot?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yeah. Okay, fine. So when two variables are highly correlated, it will result in multicollinearity problem. So the significant variable became insignificant. How to identify this multicollinearity problem? So using VIF, variance inflation factor, we can identify the multicollinearity problem. So if the value is greater than 20, then you can identify those variables are having some collinearity problem. So I will have a correlation matrix like this. In this, if you see, so you have to calculate VIF for everywhere. So how to calculate VIF? So by considering R square. So here the formula for VIF is 1 divided by, you are able to see, ma'am?
Yes, ma'am.
Okay. Okay. So
Yes, ma'am.
VIF
Ma'am,
for
but
X.
can you please explain the equation again?
Okay. So regression with, so I hope you all understood this. So up to this, yeah, this HP and SP are significant. So we cannot say that this miles per gallon MPG depends only on HP and SP, since your volume and weight are shown as insignificant. Let us find whether this volume and WT weight are significant. So kindly mute, I'm able to hear some noise. So MPG on volume. So if you calculate it separately, MPG on volume, So you can see they are more significant. Volume is more significant variable. And if I calculate MPG, it is simple linear regression. Only on volume I am calculating. So the next one only on weight I am calculating. If I calculate the p-value, as I told you, if the p-value is less than 0.05, then it is said to be the most significant value. So now in both the cases, when you consider volume alone, it is significant. When you consider WT alone, it is significant. So the problem is when you combine these both, then there is a problem. Let us find out what is the problem with that. Now, let me design an equation. MPG depends on both WT and volume, weight and volume. When you see this, again the P value is insignificant. When I considered separately, it is more significant. Now, when I combine this, then it is shown that it is not significant, insignificant. Now coming to the scatter plot. If you see across volume and WT, the scatter plot shows that when volume increases, WT is also, it is highly correlated. See, no point is away from the line. So that means both volume and WT are highly correlated. So it is one. So multicollinearity problem. So that means if one or more, if two parameters are highly correlated, then the significant variable, even though they are significant independently, they become insignificant. So I need to find out whether any multicollinearity problem is there in my system. How to find out multicollinearity problem? Using variance inflation factor, I have to find out. So if the value is greater than 20, I find there is there is a problem of collinearity. So I let us measure it. How to find out VIF? So here I know how to find out the R square value. R square value is nothing but your total variation. So that already we saw how to calculate that R square value. I hope you remember. Explain variation divided by total variation. So this formula. So same thing. What I want to do is I will apply on each and every parameter. Now you see I will calculate R square for volume. So volume depends on HP, SP, WT. Because only these four parameters need to be considered. I just want to calculate Y, which is MPG. MPG depends on all these four variables. So I have to find out among the four variables which are highly correlated. So in order to find out that, I will find out R square based on the other three variable. I will find out, I'll keep one variable as Y and the other variable as X values, and I will calculate the R square value. So in the first model, I'll keep volume as Y and other HP, SP and WT as X1, X2, X3, and I'll find out the R square and I'll find out VF value. So the VF value is 638.80. Next, I'll keep HP and it depends on volume, SP and WT, and I will apply this formula and I will find out VIF. So variance inflation factor, it is 19.92. And then your speed, so it is you are keeping speed as Y and it depends on volume, HP and WT, so it is 20. And then WT, it depends on your SPH. So among this, if you see greater than, or if the value is greater than 20, that means only volume and WT is having a greater value. So from this, we can conclude that these two values are highly correlated. Because of these two values, we are getting multicollinearity problem. So what we need to do? We have to find out variance inflation factor. So keep considering all the independent variable, and then I have to find out the more multicollinearity problem. So which variables are highly correlated. So once I identify that, I have identified two value. One is volume and another one is WT. Now what I need to do? I have to remove one of the variable and build the regression equation again. So that means my MPG will now depend on volume, HP and SP. Otherwise, It will depend on weight, HP, and SP. Why it is so? Because these two variables are highly correlated. When they both are considered to build a model, then due to multicollinearity problem, they both become insignificant and they are not giving proper prediction. So what we will do, we will consider one variable and then we will consider it. So now I'm going to consider the same process. So here with volume, I'm calculating the all the p values and see all are significant. So in the next example, I'm calculating with the WTSP and his. Even here, it is all are significant. So, for which region regression equation, so you have an AIC. AIC is nothing but archaic information criterion. Value is less, then that model is good model without multicollinearity problem. So I have identified many things like this, but I have so many combinations are there. MPG depending on volume, SP, HP, WT, MPG depending on SP, HP, WT, and volume HPWT, MPD depending on volume and HP, SP and HP. Likewise, various combinations are there. So now I just want to find out among all the models which one is the best one. How to identify that? I have to apply AIC. So archaic information criterion should be applied. So if AIC value is less, then less, then model is very good without any multicollinearity problem. So here p is the number of variables you are considering for calculating this, and n is the number of data points. So now you see, for I applied all these volume HP, SP, WT, and then volume HP, SP, and volume. So among this, your whichever model is having archaic value, AIC value lesser, that will be considered as the best model. Among these two things, if you consider 246 is lesser compared to 248.06, so I consider this model volume plus HP plus SP is the best model. So likewise, now I have built the equation properly by applying all these things, and now I identified volume and HP and SP need to be considered as a independent variable to calculate the MPG. So because its AAC value is lesser compared to all the combination. So our model, whatever you have built is perfect. Now you can use this model to predict any value by giving the input x1, x2 and x3. So this is how you will build the model. Now in general, when I say model building, first you will be given a data set. So first thing you have to do is exploratory data analysis. All those data pre-processing process, everything should be done and it should be ready for building the model. Once it is ready, you will be building the model. Once you build the model, you have to check whether any collinearity problem is there. If any collinearity problem is there, then what you have to do? You have to remove that collinearity problem and then how you have to validate the model. So if you want to delete anything based on the diagnostic, you delete it. Again, you do all the analysis, train it, and if it is perfectly kind, then you finalize the model. So these are the steps involved in building the model. So first we have to take the data set, then EDA, then model building, check for collinearity. If any problem is there, validate it and find out. You delete whichever variable is not required and then build the model again and then check for collinearity. And then if it works fine, then you finalize the model. So this is all about your linear regression, and last one is logistic regression. So here, whenever I say logistic regression, so it is a predictive modeling algorithm which is used when your y variable is a binary categorical. That means either you have to say yes or no or one or zero. If these are all the few examples. So when the response of the variable has only two possible values, it should say either yes or no, or 0 or 1, or this or that. So only two possible variables should be there. Then it is desirable to have a model which will predict either 0 or 1. So that means the probability score will range between 0 and 1. So in this case, I cannot go for a linear regression model because it doesn't have a capability to predict it. Because if you use linear regression to model a binary response variable, you should not restrict the value for y, because I am saying y should be predicted within 0 and 1. So it is not possible. You cannot have a restriction over the y variable. So you cannot apply in this case. If you want to have only two possible outputs, then you cannot go for linear regression. In that case, you have to go with logistic regression. So here the examples are spam detection, whether you are going to predict whether the email is spam or not, credit card fraud detection, so whether the credit card transaction is fraud or not, health, marketing, and then banking, in all these things. So you, if you want to predict two, if it has only two response, then you can go with logical regression. Okay, thank you all for your patience listening.
Ma'am, participants, if you have any queries, you may ask, please.
Yeah, I have one question.
Yes, ma'am.
Ma'am,
Ma'am,
when you check this collinearity with correlation among the variables, what should be considered? Because in linear regression, we will consider the p-value. If it is less than 0.5, that attribute is selected. But when we go for multiple regression, the p-value is greater than 0.5, but my R square value is greater. So which one I have to consider? Hello?
ma'am, Prabha, ma'am.
Yeah, yeah. If you have a good R square value and you have a p value is very great, that means there are some problem will be there in your data. So either it can be a skewed data, or some problem like collinearity problem will be there. That is what I was discussing. So when you have a good R value and R value is less and P is significant, or in other cases, so you have to consider other variables for finding out the y value, other than what you have considered in the linear, multiple linear regression x value. So in other case, even if you consider also if it is coming, then the data must be skewed data. So in that case, what we will do is instead of taking x directly, you will go with log x function.
Mm. Log X. Okay.
Ma'am, I have one question. Ma'am, I
Yes,
mean,
sir.
how K means clustering related to empty cluster? Ma'am, in clustering purpose, empty clusters can be occurred. So, how will I identify?
Hello.
Yes, ma'am.
Um, so please wait, sir. Let the resource person will.
Okay, ma'am. I will wait.
Ma'am, will you please send the slide to us, ma'am?
Hello?
Yes, ma'am.
Sir, I think I am unmuted. Yeah, mute. Can you hear me, sir?
Yes, ma'am. I hear.
Sir, your question is what you said, like how K-means is.
Ma'am, in clustering purpose, empty clusters can be occurred.
See,
So
I
how
would
will I
say
identify?
your K-means will provide you the local minima, but when you say empty clusters, you don't want that. Actually, you remove it. No, you will replace with that with some random value, and then you will calculate.
Ma'am, if empty clusters can be occurred, it will take some storage. So
Yeah, sir.
so how will solve this problem?
So actually, you don't want that. You will remove it, and you will replace that point with a random one.
Okay, ma'am. Ma'am, I already implemented for this kind of research, but the encryptions can be occurred. I initialized random values,
Okay.
but though empty classes can be occurred, ma'am. That's why I am asking that
Even then,
this type of questions.
okay. I don't know what data set you have taken and how you are processing.
Ma'am,
So
I
you
will take
just mail
any
me that.
random data sets,
Yeah,
ma'am.
you no random value. You said you are working on a project. Now you just send me in what scenario you are getting that and what is the problem. So accordingly, we will solve it. We are also working on some problems like that. So yesterday we got some banking related data and we were trying to, even though we did data cleaning feature everything, we our accuracy is still we are not able to improve it. So for that we were applying cross validation, like you said, so many things are there. So you just tell me your data set and where you
Ma'am,
want to change it and what result you is the problem.
I was taken my data in UCA repository.
Okay, you just mail me, sir. I'll just you can just send me a mail and you can just I'll mail to you. Okay, sir.
Ma'am, okay, ma'am, fine. But in data mining, big data, empty clusters can happen.
Yeah, yeah, yeah. You have to replace. That is what I'm saying. You have to replace Centroid, or yeah, otherwise you can use SSE. So you can choose the point which will contribute most to that sum of square error. I said no. So based on that, you have to choose the point. So many things are there. So accordingly, you have to work.
Okay, ma'am. Can I identify exact empty clusters?
Hello.
Okay,
Yes.
ma'am, fine. Tell me, ma'am. Okay, ma'am.
Ma'am, your voice is not audible, ma'am.
Yeah. Can you hear me, ma'am?
Ah, yes, ma'am. Now it is audible.
Yeah, yeah.
Any other queries from the participants? Let us conclude, ma'am.
Yeah, ma'am.
Okay, ma'am. Very good afternoon to all. Today, our resource person Prabha Selvaraj ma'am have give the introduction of machine learning And ma'am have covered various topics, data processing and types of errors and hypothesis, and basics of machine learning algorithm classifications, and ma'am have explained machine learning algorithm in regression types with more examples. I think so. Today the session is more useful for the participants. Thank you, ma'am. On behalf of Excel Engineering College Department of Computer Science and Engineering, I would like to thank our today's resource person for being with us for this STTP slot 2. Thank you, ma'am. And and also I thank the participants for conducting this today's session in successful manner. Thank you. And kind request to the participants, feedback link is given in the chat box. So don't for I request all the participants to give the feedback without fail. Once again, I thank all. Thank you.
Ma'am, please enter the today's session PP, ma'am.
Sure, ma'am.
Yeah,
Sure. Thank you.
madam. Yeah, I'll send the link. You can, I'll send it, ma'am. No problem.
Ma'am, whether you have any link or regarding your video lectures, please send also.
Yeah,
I
yeah,
can.
I will. Yeah, I'll drop a mail to Geeta, ma'am.
Uh,
Okay.
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 Thank
Thank
you.
you.
Thank you.
Thank you all.
Thank you all.